Oh, this looks quite a well used set. We've got a Uniden UniAce 100 here. This is another one of my buddy Steve's radios. He wants this fully recapping. These do have capacitors that go in them, are well known to go anyway, and very often they also have meters that either get sticky or don't work. That's a common fault with these sets. So let's pop it on the equipment and see what it's doing or what it's not doing. Steve didn't send this in with a power lead or a microphone. I'm using my own genuine audio line microphone, which should work on the Uniden, and I've used my own power cable there at the back, which you can still get the power cables for these other 3-pin Uniden type of power connector. So right, let's see if it powers on. Have we got power? Yeah. Right, it's coming on, but it doesn't sound right to me. That's definitely not right. So I'm more or less convinced there's going to be a capacitor issue with this. Let's try transmit, see if we get anything there. I very much doubt that we will. Just pop the meter into the right position. We're getting some power on transmit. Is that in the low power setting? Yeah, we're getting 4 watts on transmit. I don't know if we're getting that on frequency. Let's just check. What I'm going to do is just turn the squelch up, that's annoying. Right, the squelch isn't working, and it's very, very stiff, the squelch control. The volume control appears to work. The PA switch is switching it out. I haven't checked the PA yet. Let's just check it's transmitting on frequency and if there's any modulation. Right, there we go. So it is on frequency, but how it sounds I don't know. We'll get the Randy onto that. 1, 2. Well, that doesn't sound too good, does it? I think we have the dreaded capacitor problem. And the other problem we got is, you see there, we've got no movement on the meter on transmit, so I suspect this meter's no good. And it sounds awful on receive. There's the back of the board. It actually looks better on camera than it is in reality. It's pretty grimy and horrible. Very dirty. I think it's been stored somewhere a little bit damp as well, this, because there's quite a lot of evidence of corrosion around the bright steel parts. And it's always a worry when you take the radio apart and the speaker is disconnected inside it, because obviously it indicates that someone has had it apart and couldn't get it working, has just put it back together and sold it. I'm going to get the isopropyl alcohol and the toothbrush on the back of that. I've just given the very stiff pot a clean. Both of the pots are moving from the back. The only way to fix that is to take the escutcheon plate off the front, which you have to peel off. Right, so we've got what we need. We've got our fume extractor, HEPA filter. We don't want to be breathing in the fumes from this old set. And we've got the TC1, which you haven't seen the video, which has got the battery extension on it, so this should last the course. We've got the TC1 to test the capacitors that are going to come out, and we'll change them one by one, and then we'll also test the new capacitors going in, just to make sure we're not putting bad capacitors into the radio. Right, it's been recapped. I didn't find any particularly bad capacitors in there, so as I suspected, it hasn't cured this fault. We've still got that terribly out of line sounding receive. Okay, we're back. If you've got an Audioline PT340 or the 341 or the Uniden 100, the board is exactly the same. There's the that's what everything does if you need to do one yourself. There's a VCO adjustment there, which I'll do in a second. We just check on channel 40 for 3.5 volts, and on channel 1, what I've got there, it's 1.8 volts. We do the VCO, then we do the power, and then but it's really the receive on this that I think is going to be the issue. Right, to check the VCO, your test point that you need your meter on is that point there. Oh, these are hateful little radios. On setting this up now, I've just checked the VCO. The VCO is in, but then I noticed whilst I was keying up for any length of time, you see there it's not going into transmit at all now. And then No, it's still not going into transmit, and when it was going into transmit just now, the power was dropping off, so it was at 4 and it was dropping down to about 2.5. Right, after a bit of a tune-up, it's now stable, at least it seems, for now anyway. It's only doing 3 watts, but it's not dropping like it was before. I was just about to break out the thermal camera to have a look to see what it was doing, but just at the minute it's not dropping. But we'll have to keep an eye on it, and we'll have to run some transmit tests. But 3 is about as maximum as I can get out of it at the minute. I think I found the culprit. If I tap underneath the channel switch, see that? There you go. That's gone and it's come back. So there's a bad contact inside the channel switch. Right, fun of joys. There it is there. And they're sealed units, but a little trick I've done in the past is drilled a tiny little hole in the top in between the 2 switch plates, and then just got some switch cleaner in there. So what have we got to lose? I do have some scrap chassis of these, but I'm pretty sure I don't have a channel selector. I could be wrong, I might have one, but oh, that's so much work. So it's almost there. Now the TX LED has decided to stop working, and we've still got the meter to sort out. So yeah, guys, bear that in mind when you see these come up as unit ends or audio lines. You could be in for a whole lot of work. This has basically took me a whole afternoon so far, 4 hours. And if you're doing this commercially, like for your living, yeah. Right, there's our LED, 3mm. I haven't checked to see if we are getting the signal, but I'm just going to change it over for a new one. Right, you can have yellow, red, green, blue, or white. I think we'll go with red, eh? And just quickly put it on to test. There we go. Lovely job. I just wish the meter worked, but there we go. This is the next job. Of course, the meter is open circuit. I've just disconnected it there, and it's open circuit. I don't have any spare meters. There we go. There's some more Uniden labels. Uniden. I've actually managed to get the font as well. Uniace 100. Right, we're just sorting these labels out. While I do that, I'm going to try and do something with the meter. And what I'm going to do is, on a good radio here, I'm going to measure the resistance of the meter first. And we're going to look at a nifty little replacement idea that I've had. I don't know how well it's going to work, but we'll see. So let's just see what the resistance of the meter is, and then also see what kind of voltage, when we put a full signal on the meter, what kind of voltage it's looking at. Right, so the resistance of the coil is 656 ohms. Okay, we're just going to try it across the back of the meter. So if you've ever wondered, 656 ohms. Right, so with a 1000 microvolt signal on S9 on the meter, we've got a AC signal here of 4.79 millivolts. So that's what we've got off the back of the meter. Now, so what I was thinking of doing was dropping the original, here's the meter, because bearing in mind, to get one of these meters, for us in the UK, these are £25. Now that's probably more than the radio's worth, and they're getting much harder to get hold of. So what I've done is I've took the backing off the meter there. I'll pop that there and just show you what I intend to do. And I've got these inexpensive bar graph displays. Now you can get these as like traffic light types, or you can get them as just this one is a standard green one. And what I intend to do is to pop the, I'll 3D print a different clip for this, but we'll pop that in there, and we'll obviously align the label up properly, but pop that in there and then run a bar graph driver, the LM3194 IC, run that driver to drive it off of that signal, and I can just basically cobble the chip off the back of the display there, nice and easy. It's a very simple circuit, and then that will give us a line that goes up and down similar to the signal meter, and I think that's going to work quite well. Now of course you can get, you can at any time in the future you can change it back to a moving coil meter, Obviously, if you've not got a meter there at all, there are things you could do. 3D printing a little holder to hold this and drop it in. But I think it's going to work quite well. Let's see how it looks anyway. And like I say, this is Steve's radio, so we can always change it back to something different afterwards, or change it back to the original one. But I thought I would see how this technique works, and it might be something you can try just to give you a sort of rudimentary meter for the cost of only probably a couple of pounds. That's it, that's all it will cost you. Right, just a little mock-up here. We've got the bar graph display there and the bar graph display, the LM3914. Now the only problem with the LM3914 and driving these signals is we know, because we've measured it, that our signal is 5 millivolts. So we can't use a 5 millivolt signal with this, because the minimum signal that would represent full scale is 1.25 volts on these. So you need to upscale the signal coming from the meter control circuit in the CB. And that's where these little boards come in. Now you might think, oh goodness me, this is getting expensive. £1.50. So that's £1.50, right, off of AliExpress. And what this will do is it will take your 10, let's say maximum on some CBs, your 10 millivolt full scale deflection CB signal, and you can then adjust that out to whatever gain within reason that you need to drive into the LM39143. You can actually see we've got the system set up here. The bottom signal is the input signal, which is 1.9 volts peak to peak, and then the top signal is the amplified signal, which I've got set currently at about 6 volts. And you can see there's obviously noise on that lower signal there because it's a smaller signal, and these cheap signal generators are a little bit noisy on the lower end. And in fact, I can't actually set that to 10 millivolts. It hasn't really got the resolution to do the test. So all that we can really do is to hook this up with our board here and see if it correlates to anything meaningful on the CB. There you can see we've got the thing all rigged up. We've got our voltage signal on 1.19 volts there. So we've set the resistor configuration on here to see a full scale of 5 volts. Okay, on here. And so as we wind this voltage up, we should see then the bar graph increase correspondingly. And we're basically simulating the low signal from the radio. So we will test this with the CB in a minute, just to make sure it's definitely going to work. That'll be interesting. This looks way complicated, but it really isn't. What we've got here is we've got the connection from the back of the meter, so we're going right across the meter into this signal board, which takes the 5 millivolts signal from the meter and turns it into a 5 volt signal, so it's 1,000 times more. And that 5 volt signal we're feeding straight into the LM3914, which in turn drives the bar graph. There we go. So you can see there we've got there's our signal on the CB. We're representing that in the same fashion, and you can see that get the glare off the top of it on the bar graph. Now what we're going to do is just turn up the signal on the signal generator, and I'll show you the signal as we increase. There you can go, there's a little blip there, and as the signal's going up, it's going up. Our little blip's just my signal generator. There we go. So we're about halfway there, and there we are about halfway on the CB there. Bearing in mind we can calibrate once this meter's into the radio, not in this radio but in this radio, which is the Pauly radio. We can calibrate the meter using the onboard control, so this doesn't have to be exactly spot on. So there we are about halfway there, and then we'll wind it all the way up just to show you. We'll take it all the way up to need to go in the right direction, all the way up to 100 microvolts, which is our S9 signal, and I've set this roughly to be around there on the meter. So that's our 100 microvolt signal, and you can see it's a little bit low actually on this meter. I need to actually tweak it, so it's absolutely spot on compared to this meter here. Now you can, as I mentioned previously on the video, you can get these displays with red elements in the end. I haven't got any of those. I've only got the green one. So just for now, as a trial, we're going to pop this in for Steve as it is, with just the green display, and I'm going to get Steve to run this for a bit. Now what I'll do is I'll put the decal from the meter over the top of that, so you can see how this is going to work. There you go. You can see that. So we can see how the segments are lit over the existing decal off the existing meter. So I think that's actually going to work quite well. That's going to, obviously it's not as accurate as the needle, but then the needle isn't really accurate to anything anyway. I think this should look quite nice once it's actually in the meter. And like I say, then if you get the red LEDs, so when it goes into the red zone, that would look even nicer. And of course, if you wanted to, you could just run it. You could just run it like that with the green displays, like an Amstrad type style, if you wanted to. That wouldn't look so bad, would it? Let's be honest. So let's get something. We're going to have to cobble this together a little bit, but let's get something cobbled together that we can pop in the radio as a test. And like I say, if this works, I think I'll probably get on the design software and get this all onto one board. So that might be useful. I can perhaps sell a few of those if people have got this problem, because like I say, it really is. I've got scrap chassis around, lots of really good scrap chassis that are basically you know, I can't get the meters for, and they're only really good as scrap chassis if you can't put a some kind of meter in there. So yeah, I think it's a fun, interesting little get around, really. Yeah, I'm pleased with that, pleased with how that's come out. There is another mode you can operate this in as well, so we start off at the low level. It's called dot mode. It's just a link that you remove off of the chip, off the LM3914, and in this mode it will actually go up as a segment. Well, it goes actually in between. You get a bit of overlap in between the segments. So that's another way of doing it if you wanted something a little bit more, you know, in between. And also it's less work and less work on the LM3914, because LM3914 gets quite hot when it's operating with all the segments lit, because it's got to drive all the LEDs, and it uses much less power in this mode because it's driving less LEDs. So that's a useful mode, the dot mode, that you can use this display with, or use it in. So there we go. Right, we've made the little board. This didn't take as long as you might think, just on a little bit of VariBoard, and really a bit unconventional because we're soldering onto the copper side of the VariBoard, but you know, I'm a radio ham, so we can do stuff like that. So you can see what I've done there. We've commoned up the anode, and then we've just got some links and the resistors on the back. I've put a smoothing capacitor on here because on this radio I am going to use a little regulator as well, because it actually, with all the LEDs on it, actually does draw a fair bit of current, and I don't want to destabilise the radio. So on this one, as it's a bit of a test, we're going to use a regulator. And also the signal board, that needs, you don't want to be putting more than 10 volts into that anyway, so you do need to find a regulated supply. Most radios have got a regulated supply that will run this. Of course, this takes absolutely no current at all, so you can always find somewhere to stash that in the radio, no problems at all, which we will do. And what I've done to center the display in the bracket nicely is I've 3D printed this little piece that will sit inside the display. It fits really snugly over the display, and it will center the display in there. So let me just assemble that. I'll find the there's the decal for the display. I'll find the decal. There's the bit to focus. There's the decal. So we'll pop that in, and I'll assemble that and show you what it looks like. And then it's very late now because I've been updating the firmware on my 3D printer, but oh my god, I think it was worth it. That's printed really nicely. It's come out nice, and it's a very fine, delicate little print, that, so we're pleased with that. I'll just assemble that, and then in the morning we'll hopefully get it all together fairly quickly. Right, there's the regulator installed. We've got the CB powered up, we've got it on channel 20, and there's our little signal conversion board, and here is our meter. I'm really pleased with how this has come out. Now I would be nice to get some of the red LEDs for the final section there, but I haven't calibrated this yet, but it is doing about 5.5 volts output for the 100 millivolt 100 microvolt signal. So we've got our 100 microvolts, our S9 signal on the signal generator. I'm just going to start winding it down, and you'll see how this works. That little flicker you can see, don't worry, that's my signal generator. It does that as it jumps down. So you can see the signal decreasing and decreasing down, all the way down to below 1 microvolt, and you can see it flickering there, and actually when there's no signal it goes off. So Now, of course, you could take the original, you could take the actual, the bit of plastic out. Now, you can actually see a better gradient. The camera's not doing this really justice, but the actual definition, if you like, is better with the naked eye. It's kind of sharper, if you like. But these things are kind of woolly anyway. It's just more of a nice visual indication of the power. There we are, getting up now, going up into the red. So this would definitely be better with the red LEDs at the end. But still, I think that looks really good. It's a really nice a nice little setup. Now I think I can probably push that in a little bit more. There we go. So yeah, I'm pleased with that. I think that's going to work really nicely. It's certainly better than not having any meter at all. And there we go, installed. Now this isn't a permanent installation, this is a test mule, so we just got the leads just on the sockets and the pins there, and I've used a little bit of double-sided tape and stuck that onto the channel selector ribbon cable there. So that's nice and secure, that's not going anywhere. As mentioned, our voltage regulator there, just to take some of the strain off of the, we don't want to be pulling down the existing 9 volt, 8 volt, 9 volt rail in here. So I'm going to do a tiny little mod. I put a 1000 microfarad 35 volt capacitor across the pickup supply from the regulator there off the board. So this is the 13.8 volts that goes off to the regulator and then comes back. Because you get a lot of, well, you can get switching noise on these LM3914s because it's switching, you know, with all the 12 LEDs on, it's pulling a fair bit of power there, a bit of a supply dip, and it can go into an oscillation. So I found the best thing, as it does say in the data sheet, I popped a 1000 microfarad capacitor in there just across the supply, and that sorted that problem out. Here's the underside of it. There's the bearer board and our connections. I've left the bulb in there, just tied it, just stuck it in there loose and disconnected the ground from that so it doesn't light up. There's the doorbell, and there it is from the front. That's all supported nicely. So we'll what I'm going to do is going to put these labels on now, because I'm going to just clean up around those pots. I've tightened these nuts and I've tightened that nut there, and we're going to put the new labels on. There we go, that's looking a lot better. We've got the new labels on, and they're certainly better than the ones that were on there, aren't they? Yeah, like I say, I even managed to get the UniAce, the proper font there for the UniAce 100. Right, I think we've still got a bit of setting up to do. I just want to set the S meter up. We'll set that up and I'll go for a few bits of testing, and then we should be right to have a little test with Mick. Right, that's good. We got about a what you would call a half a radio 4, radio 5 type signal there, and that ties in with my other sets, so I'm pleased that that's good. Dropping things on the floor, and we'll try it in transmit. We'll just adjust the transmit as well, and I think we're good. Yeah, I mean, it's certainly different, isn't it? I know it won't appeal to everybody, you know, but there you go. It's a little bit lower on transmit, so we'll just adjust the offset for transmit. What Mick is about, he's just setting his camera up at his end, and we'll see how we get on. Typical noisy conditions, as I get a lot of background noise here, as you can see on the meter there. Lots of crackling and stuff on channel. We'll try and find a clear channel, and then we'll go from there. Okay, Rog. Okay, here we have the Uniden UniAce. We've got Mick on the channel there, and this is one where I've put a new meter in it, Mick, and it's had a new labels on the front, all bells and whistles there, Rog. I wonder how it's sounding to you there. Go ahead.
Yeah, afternoon, Paul. Yes, the UniAce is coming through really well. It sounds nice at this end. I've got no complaints on the audio at all. Excellent.
Yeah, Roger D. I'm just testing this little meter of mine that I've made. If you've been watching the video so far, people will see what I've done there. This is a bit of a test. A bit of a test really. I'm going to refine it a little. Right, coming back to you now, Mick. We've changed microphones. The audio line mic, I think, might have needed a bit of a clean. It was getting a little bit of intermittent audio problems, and that was just the microphone. I've got the this
new Rode King microphone on here, which appears on the SDR to be performing normally, so just a bad contact. So yeah, I'm really pleased with this. I know it won't be to everyone's taste, but again, if you've got the money and you want to, you can just pop a new meter in. They are £25, very expensive just to replace the meter, whereas this can be put together for £2 or £3, and it's a fun little rainy Sunday afternoon project, I think. So, but apart from anything else, with the new labels on, I think it's looking a lot better, and it's certainly back in the land of the living, and it was very much in the land of the dead before, so that's a good thing. So you're giving it the thumbs up on the audio there, Mick. You're quite happy with how it's sounding now, Rod?
This new Rode King microphone on here, which appears on the SDR to be performing normally, so just a bad contact. So yeah, I'm really pleased with this. I know it won't be to everyone's taste, but again, if you've got the money and you want to, you can just pop a new meter in. They are £25, very expensive just to replace the meter, whereas this can be put together for £2 or £3, and it's a fun little rainy Sunday afternoon project, I think. So but apart from anything else, with the new labels on, I think it's looking a lot better, and it's certainly back in the land of the living, and it was very much in the land of the dead before, so that's a good thing. So you're giving it the thumbs up on the audio there, Mick. You're quite happy with how it's sounding now, Rog?
Yeah, okay, Paul, receiving you. You're using a Uni-Ace. I think you said Uni-Ace anyway.
I said Uni-Ace anyway. And the audio quality is very, very good at this end. And I don't need to make any adjustments with anything anyway. So all I'm doing is recording what you're sending to me. And it's coming through on the Thunderbolt C800. You sound very good.
Yeah, Roger D, and you're a very good signal with me today. About between a 7 and an 8.
Between a 7 and an 8 on this new meter, flickering between 7 and 8, so that's good. And that ties up with the C800, which I've got monitoring as well. So I'm pretty happy that this meter is as accurate as it needs to be. It's accurate enough for CB radio anyway. And I hope it gives someone, a bit of an idea what they can do. And it's always fun playing around with electronics. It's part of the hobby that I think, particularly in the amateur radio side of the hobby, that's sort of dying off. So I like to encourage folks to do it. And if people want to see how to do this, I'll put a PDF link in the description so they can get hold of a wiring diagram which shows how to connect all this together, right? Yeah, okay, very good. All copied. I can't wait to see the video now and see what you're talking about, Paul. So, yeah, I always have to wait for the video, don't I? Yeah, so I don't get any previews. Anyway, it's very good with me, and I wouldn't worry about that at all. If it was mine, I'd be perfectly happy with it.
Yeah, Roger D, I'm glad you like it, and hopefully Steve will too. And I've said to the owner, to Steve, that if he wants to put a normal meter back in there, which I think he does have one, he actually did buy one in the end, but I'm more than happy to swap it back.
This has been a bit of fun, and when I get 5 minutes, I'll perhaps make a circuit board with all of this on one board, and it might be a bit of fun to do that. So, okay, if you have been, thank you ever so much for watching this slightly extended episode. I hope I've given you some ideas. You can, of course, once you've got one of these signal boards in your radio, you can use something like one of these little ESP32s, because you've got the signal level at 5 volts now, and you could have a display in there, a nice TFT screen with graphics on and all sorts.
Okay, well, if you have been, thanks ever so much for watching, and we'll catch you on the next one, and thanks for your help, Mick.
Okay, Paul, all copied. That all sounds very interesting to me, so I will admit, though, there is a little bit of white noise received at my end. That's possibly just because I'm on a mag mount on the shed roof at the moment, and it's not on the antenna that's down the bottom of the garden, but still receiving you loud and clear.
Right, I hope you enjoyed that. I think you'll agree, from a sort of tired old Uniden, it's really looking nice now with these labels, and I think even the meter, it's something different, isn't it? Of course, bear that in mind if you buy any of these Uniden based radios. They can often be very problematic, and you'll always have to change the capacitors, and they get hammered. So yeah, there'll always be work in there for you if you like fixing CB radios. Like I say, I'm really pleased with how this came out, and once that board is in there, you could put
little ESP32 and Arduino in there and do all sorts of tricks with it. You know, I still think these, with the screen on there, it doesn't look too modern. It's just a refresh. And I thought some of you might like to try that. If you get some time, you might have an old set where you haven't got a meter, and you could, with a bit of clear perspex, you could knock something up to suit. So I hope you've enjoyed this. If you haven't already, please like and subscribe. It really, really helps me, particularly when you subscribe to the channel, because it tells YouTube that more people should watch the videos. Okay, take care, have a great weekend, and we'll catch you on the next one. Oh, and before I go, there is a link in the description for a PDF of the schematic of how I connected all this up. Remember, on some CB radios, you will also need 1000 microfarad capacitor because, like I say, the chip does draw a fair bit of current. So there you go. It's all there in the description. If you've got any questions, just leave them in the comments and I'll hopefully try and answer them for you. Take care.